Okay, we're going to take a look at number 7 in section 7.7. Again, we're looking at whether this, in this case, improper integral converges, and if it does, we're going to evaluate it. We have an infinite limit of integration, so we're going to be using limits, but I'm going to go ahead and do the change of variable on this first because finding the antiderivative of this, which we're going to have to do eventually, is a little bit tricky. I'm going to let u, hopefully you see, to be 2 plus x to the fifth. Du is 5x to the fourth dx by the power rule. And I've got x to the fourth dx, so I just do 1/5 du is x to the fourth dx. I'm going to also change the limits. The lower limit is 0. And if I plug in x equals 0, right, I'll get u is 2. The upper limit is approaching infinity. That's what this means. So x is going to infinity. Well, if x goes to infinity, you clearly can see that x to the fifth will go to infinity, and u also is going to infinity. So I can rewrite this as the dx, right, is x to the fourth dx is 1/5 du. I've got 2x plus 5 is u to the second power down here in the denominator. And again, remember, we changed the limits of integration. X equals 0 is now u equal 2. And then the top limit is going to infinity and also going to infinity here. So now I'm going to rewrite this with the following. Limit as t goes to infinity, right? Of the 1/5 the integral from 2 to t. I just rewrote u 1 over u squared as u to the negative 2. Power rule on that, the antiderivative is negative u to the negative 1, or negative 1 over u. Plug in t, I get negative 1 over t minus a negative or plus 1 over 2, right, when I plug in 2. Now I can take the limit as t goes to infinity. The only thing that's changing is this fraction here as t goes to infinity, and that is going to go to 0. And so our limit is 1/10. The integral converges, and we have evaluated it. The value of the integral is 1/10. Okay, pretty cool problem. I hope that helps.